Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. And today I want to deliver my presentation about fluoride adsorption using nickel slag. Why the fluoride must be removed? Fluoride with high concentration in drinking water might harmful to our health, and the concentration of 1.5 to 4 milligram per liter can cause dental fluorosis. And if the more concentration, about 4 till 10 milligram per liter, it can cause dental fluorosis and scleral fluorosis. But the other hand, the consumption of the drinking water containing optimal amount of the fluoride, 0.3 till 1.2 milligram per liter, has beneficial effect on the teeth by hardening enamel and reducing the incidence of caries. This is the study like Adsorption before. Adsorption in 2015 studied about AL slag was unable to absorb fluoride by 93.62%, while acid slag was unable. And Zahar in 2015 too, steel slag was capable of removing manganese, 93% of percentage removal at pH 3 till 8. And Kumari in 2020 activated FEAF slag was able to remove fluoride 97.42%. And this is the material that I use. I need natrium fluoride, span region, acrylic zirconium fluoride region, nickel slag, and fluoride acid. This is the method of the preparation nickel slag. I must reduce the size of the nickel slag into 100 till 200 mass, and after that I characterize the sample with XRI, XRD, CM, and BT. And nickel slag with 0.75 gram, 1 gram, and 1.25 gram of the weight mixed with 50 milliliter of fluoride solution, which concentration 12.17 milligram per liter and a pH of 4, into the beker glass, 250 milliliter, and shake in the saccharometer bed at 25, 35, and 45 Celsius. And the solution samples were taken every 5 minutes. And then I analyzed for the remaining fluoride by using a visible spectrophotometer at the maximum length of 570 nanometer using spot zirconium acid region. This is the removal rate of fluoride. We can calculate it by this equation, where N is the removal rate in percentage and CO and CE in milligram per liter are the initial and equilibrium concentration of fluoride. And from the XRF, we can see that the domination of the chemical composition of nickel slag were calcium 40.57%, silica 35.57%, and the aluminum 10.93%. And the alumina content in the nickel slag determined the amount of fluoride that was absorbed. And from the XRD, the morphology revealed that the surface structure of the nickel slag was almost split because there was no pores at the adsorbent surface. And this from the XRD, we got the major the crystal paste where Al artemanate, lime, nickel silica, and nickel, and the BAT surface area was 0.0. So there is no pore here. And the effect of the adsorbent dose, we can see that here the adsorbent of the fluoride very fluctuative with the time, which is indicated that the bond between the fluoride ion and the adsorbent was a weak bond. even though with increasing the absorbent dust. And the effect of the temperature from the 25 to 45 Celsius, the absorbance of fluoride still fluctuative, and that indicated that absorbance was PC absorption, and the amount of fluoride absorbed was less than 18%. And the conclusion of this paper about the amount of fluoride absorbed by the absorbent fluctuated with the time, which indicated that the bond between the fluoride ion and the absorbent was psychosorption. This absorption, which is have a weak bond. The amount of fluoride absorbed was less than 80%. I think that's all. Thank you for your kind attention. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.